Git, learning the fundamentals of Git. So today we'll be looking at Git and understanding how it works, what makes it work, why do we have GitHub and Git, and why do we have companies like GitHub, Bitbucket, um, and other version control companies out there. And then we'll also look at some ways to branch your code and make it easy to develop and collaborate with others. So welcome to today's show and today's talk. It's good to have everyone here. Um, so without wasting any time, because we're already 30 minutes behind, and that's because we had to send out calendar invites to everyone, and then we had to move it to 7:30 at the last minute. So thanks everyone for joining. We'll be starting, so I'll share my screen. But first of all, I'd like to introduce myself. My name is Chilo Mokola. I'm a software engineer. I've been a software engineer for 6 years now, and in these 6 years, I've had the opportunity to work across different industries and solve problems in different industries. Right now, I'm trying to help other people get into software development and also help people who are trying to build their products achieve that goal, which is managing their product development end to end. And that's also what we do at Gloves. So, all right. So we can start. Keep learning the fundamentals. Now, what makes a developer happy? First of all, is a merged PR. The moment you see that your PR has been merged, or let's say pull request in full has been merged, a developer is usually excited. The developer they feel like the load has been taken out of them. Now, people that are not really used to the whole developer language and the way we work, they will not really understand it. And that's because it's it's weird. It's not their language, right? When your PR can be held and you have comments upon comments upon comments, and you have to keep fixing stuff until those things are done, your PR will not be merged. But when it's done and you're finished fixing everything and the reviewers are happy with the code you've pushed, then your PR will be merged. And when that is done, it's it's it feels good. I really don't know how to explain it. Now, another thing that can make a developer happy is when a merge conflict is resolved. Now, Git helps us to manage big projects. With Git, 1,000 people can collaborate on one project and you have reduced friction because a project can get really big. Why am I saying 1,000 people? But 1,000 people might be an might be too much. But let's say 20 people, 50 people can work together on one code base. 1,000 people can as well. You have open source projects with a lot of people working on it. And all of these is possible with Git. Now, these projects can have merge conflicts. Merge conflicts can come up when two people make changes in the same file or modify the same line of code. That is when a conflict happens, especially if one pulled from the base branch before the other, and they make changes in the same file. A merge conflict can happen. So when this happens, it can take a lot of time to fix it. Because after fixing it, you might actually introduce an extra bug if you're not careful. So the merge conflict resolved is another thing that people are excited to see. So now going forward, let's go into Git and understanding what Git is all about. So Git is a free open source distributed version control system originally created by Linus Torvalds in 2005. Now, Linus Torvalds is a software developer. He was actually the guy that invented the Linux operating system, and he has a lot of stuff under him. He was the guy that created Git, and Git was to It was to help a lot of big software companies collaborate easily. Initially, they'll write code in different files and then zip and send to each other. They zip and send and then combine later. Git solves that problem where every single person can work on the same code independently, and you don't have a lot of cancel, you don't have a lot of deleting, and you don't have a lot of code missing when you are ready to go live. So Git solves that problem for us. Now, what is a version control system? A version control records changes to a file or set of files over time so that you can record specific versions. If you've been using Google Docs lately, you'll notice that they have a version control system there. So I will show a typical example on Google Docs. Let me open Google Docs. And you will see that if you create a new file, you'll be able to, after a couple of minutes, it will save. And you can come here and you see the history of the document. This is a version control system. It's not just in Git. It's not just in GitHub. They use it in Google Docs. It's used in Figma. All of this, like anywhere you have collaboration, it's always advised that you have like version history. That way you can track changes. You can see the people who made the changes. You can go back in time and then remove it. You can come back here. So I made this change by 7:37 and now it's 7:38. Let me add extra text and it saves. And when I come over here, I can see the change I made by 7:38. I can see the change I made by 7:37. Oh yeah, that didn't update. But I mean, oh yeah, okay. So this is 7:37 and this is 7:38. So yeah, that's just what Git is version control is all about. Being able to see where you are and also traveling back in time to where you were. It can be a year back, it can be 6 months back, it can be 10 months ago, it can be 10 years ago. Everything is saved in your Git file. Now, why do we have version control systems? It allows you to time travel in a project. You can have a project. Recently, I encountered a problem while working in a code base. The someone someone created a bug and pushed. Now, I didn't see this bug on time. I started working. Then I started working on the project. But when I build locally, then trying to push, before I push to the remote repository, it fails. I had no idea where the error was coming from. And my text editor and the build error, they were not helping. The two of them. It was just not helping. After like 2 days, 2 days, yeah, it was 2 days. I just said, okay, what will happen is I'll go back to the last commit I did because this error was not happening before when I did my last commit. I went back to my last commit and tried building and it built successfully. There were like 20 commits between where my last commit was and where I was at that point. I had to go through each and every one of them, building separately, till I got to the commit that caused the error. I got to that commit. I went to the commit history. I went to the pull request, checked the pull request, and found the bug there, fixed it, and brought it back to the future, which is where the code I was writing at that point. It was already fixed there because I had already fixed it somewhere else. And that's it, unified everything and moved forward. It took some time, but I was able to go back in time to fix that error. Now, we'll be going straight to like elements of a Git workflow and how it works. So when you create, and all of these things, I'll be practicalizing them, but it's always better to understand where you are to understand the problem we are trying to, and the problem a solution that we have is trying to solve, and it will help you to use it better. Now, the elements of a Git workflow, you have like the working directory, the staging area, the local repo, which is the head, and then the remote repo, which is the master or main, like we have it now. GitHub has stopped using master. They now use main in GitHub. How do you move from the working directory to the staging area, to the local repo, and then to the remote repo? It's all from using your Git commands. Now, your working directory is what you have on your local host, on your local on your local system, on your system, which is the local host. Let's say you, so I'll, so is a this is a folder I created for this class. This folder has nothing inside. It's empty. Now I have I want to create I want to write an addition function here. I want to add an addition function here. So let's say I create a file. Let's call it index.js. I have my index.js file here. Let me open it on my VS Code. And please confirm you can see my VS Code. Yes. Now, this is my local file. I don't have Git installed here yet. When I bring in Git, if I want to start to introduce Git here, what I'll do is I'll do Git init, and Git is now here. So let's say I have a function, and I'll use JavaScript because this is my primary language. So let's say I want to write a function that will you pass in two variables or two parameters, and it adds the two and returns an answer to you. So let's call it sum A, B, and A plus B. It returns this. I have this here right now. This is what I have in my local host. This is what I have in my local repository. This is here, this working directory. Now, this is not committed yet to GitHub. And sorry, hold on. I need to open this folder. Open. Save. Awesome. Yes, I trust the authors. And that is it. So these are like some of the security features VS Code gives us as well. Now, if I want to commit this right now, this is at this point, is at this point. It hasn't been added to the staging area. So if I try to commit, it will not work. And I will explain what commit is later on. For me to commit this and get it to a point where I can push it to the remote repo, I need to first of all add it to the staging area. So you have every Git project has this workflow: the working directory, the staging area, the local repo, and then the remote repo, which is where everyone has access to it. The working directory is where we are right now, here. And the staging area, if I want this to go to the staging area, I'll do git add index.js, and it's added to the staging area. With VS Code, you have like a visual idea of what is going on. These are stage changes, and this is not stage. Now I can move this away from the stage change by I can move like the new changes I make away from these stage changes by making by making modifications to this file. Like let's say I add a const multiply function which will multiply A and B. Now this is staged, this is not. And it's very interesting because that's also where Git shines. You can commit a part of your code without committing this other one. So I'll create a remote repo to use for example while we progress. But let me go back and remove this. I was just trying to show something. So going back to where we are, working directory, we have our staging area, which is where this file is now. Local repo head. If I want this now to be in the local repo head, I'll do git commit -m, which is the message. Git commit -m message. What message do you want to say? There are a few commits rules, but we won't be focusing on that here. So we can say add some function, and the commit has been added. And this portion of code can now be pushed to our remote repository. Now, there are different organizations that help you manage your Git, your projects that use Git. You have like Bitbucket and GitHub. This class will not be complete if we don't at least create a Git file, a GitHub repository and push our code to GitHub. Just this sample code. So what I'll do is I'll open GitHub. I'll create a new repo. Let's call it GitHub class, GitHub Masterclass. There's nothing, I don't want anything. So I've created a new repository for myself, a remote repository where I'll save this thing and anybody can access it. And I think I forgot to show us a few things. So I'll go back to creating a new repository. You can create a template, a lot of templates, or there are lots of templates actually on GitHub that you can use. This is the repository name, which is the name of the repository I just created, GitHub Masterclass. The description. A repository can be public or private. If it's private, nobody can use it apart from the people you invited. If it's public, anybody can access it. A lot of the open source projects that we use are in public repositories. You can add a README file, which the README file gives information around the project. So when someone opens it, they see a README file and they can understand what the project does just by looking at the README file. Then you have a git ignore file. This is for projects. Some projects, when you're working on them, while working on some projects, you don't need to save some information. Like if you're working with NPM, you don't need to push your node modules to GitHub because that would be a lot of data. GitHub doesn't need that data. So you can add a git ignore file. Then you can choose a license. These are different licenses. I know someone working on a on a um on a VS Code extension that will help you choose the right license for your project here. So these licenses are different licenses that you can add to your project. The most popular one is usually MIT. I think this is what open source projects use. So that's how to create a repository. And like it says, this will set main as the default branch. The default branch right now for your GitHub repos is the main branch. Initially was master, but during the Black Lives Matter campaign, they had to switch to main to remove the master idea from the world. So moving forward, we've created a repository for this example, and the name of the repository is GitHub Masterclass. Now, I want to be able to access this repository from my local hosts. Now, there are a couple of things that I have to do first. First of all, I need to add the GitHub, add the connect my remote repository, my remote account to my CLI, to my command line in my system. Now, I've done that already. If you want to know how to do it, or you've not done it before, you don't use SSH to access your GitHub, all you need to do is just Google GitHub SSH, sorry, add new SSH to GitHub. If you're using a Windows, you can add Windows. If you're using a Mac, you can add Mac. And you have step by step on how to add a new SSH to your project. Now, on your GitHub, on my GitHub, I have a couple of SSH, a couple of keys that allow me to access my remote repository from my local host. So settings, to access that, you go to your settings, where are down, SSH and GPG keys. You add it, and you can use this for like a lot of accessing a lot of things. You add this, and that's it. It creates a key. You have a public key on you put the public key on GitHub, and then you save the private key on your system, and then it makes it for easy communication. And then it makes communication easy between the remote repository and the local host, and the local repository rather. So now, what do I do? Everything is here. When you create a new repository, the steps are here. We've already done Git in it first. We've not done Git add readme because we don't have a readme.md. So well, let's create a readme.md. Oops. So I can just, and this will create a readme.md file for me. And I'll call this GitHub Masterclass. And if you want to know what your Markdown class, what your Markdown file looks like, you can download a VS Code, um, a VS Code extension called, I can't remember, something Markdown viewer. And then you can see what your Markdown file looks like. So we have a readme.md, git commit -m, first commit. We've already done our commit. You can see it here. Add some function, git branch -m main. Right now we are in master, so we'll move the commit to -m, right, main. And all our changes will be moved to the main branch. Git remote add origin, this. Now, if you don't do this, your local repo will not be able to pick a remote repo to push your work to. The origin is a placeholder for this. Now, cool thing is, something that is cool is you can have an origin, you can have an upstream on the same project, and they will point to two different repositories. Everything depends on your choice. So now let's add this git remote add origin. I'm not going to type it, I'll just copy and paste. And it has added it. And if you want to see your remote origin, you do git remote -v, and it will show you your origin. Sometimes you might want to push something to GitHub and you have some errors. You want to first of all check if it has an origin added, if there's an origin. If it's not there, then it won't be able to tie your local system, your local host. It's not really local host, but your local application to the remote server. Now, git push -u origin main. The -u is, it just tells the system that I don't need to put this origin main every time when I'm on this main branch. So let's do that. Let's run this command. And when I refresh this, Oh yeah. So I added the README, and this is good. We did git add for index.js. And when we created readme.md, we did not do another git add. So readme.md, the git, um, our git history did not see this git readme.md because we did not add it and we did not commit it to the changes we wanted to push to GitHub at that point. Therefore, this readme.md was ignored completely. Now, you can see here that you have the index.js, and this is the commit I made. If I click on this index.js, I will see this, but the readme.md was not added. Now let's add the readme.md to the next push. And right now you can see that I did git push dash u origin main. I won't need to push this dash u origin main as long as I'm in the main branch. So let's do that. So git add readme.md. And you don't have to specify the file. If you have a lot of files, like 20 files, you can just do git add dot and it will select everything. It will just do git add all. So git add all readme.md has already been selected. Git commit dash m, which is the message, add readme, git push. And when we refresh this, GitHub Masterclass, our readme.md is here. So that explains this whole workflow. The working directory, which is the local host, before the local directory before we did the git add, the staging area, after doing git add and then selecting what we want to add to the staging area, the things that are added to the staging area, that's what we have here. Commit pushes it to the repo, to the local repo head, and then pushes it to the remote repo, which is this. Now, anybody can see what I have in GitHub Masterclass. Anybody in the world, as long as I send this link to them, they have access to it. Now, when you're done, let's say you want to, let's say I have a, let's say I share this project with, well, we have a couple of people here. We have Mariam, we have Daniel. Let's say I share this with Daniel, and Daniel wants to pull it. And Daniel wants to clone this repo into his system. All he needs to do is, and GitHub makes everything easy for us. You have steps on how to do it. Git clone, copy this. So I'll just type the command here. Sorry, I'm using a lot of command lines, and that's because it just depends on which is closest. Git clone, and then you put the link, and it will clone the repo here. Now, GitHub, going back to the definition of GitHub, open source distributed version control system. The history is in the user's system. The Git history for every single public repository or for every single repository you're working on is in your system. So you don't, there's a central server, but the central server does not control everything. The local servers, let's say we have 1,000 people working on the same application or on the same repo. They all have the Git history, an up-to-date Git history on their local systems, and that is what makes it distributed. Now, I'm going to pause here to entertain questions. Do we have any questions based on the things we've talked about so far? And if you have questions, please raise your hands and I will call on you to ask your question. All right. Okay. Um, Joshua, your hand is up. Please ask your question.
Okay, good evening, everybody. First, I'd like to appreciate you for this. Thank you very much. I just have one question. I think I'm a bit confused about something. You made mention of the SSH. There's this usual way we used to do it, or they actually took over the SSH. So, I just want to confirm and ask, which is the best practice? Is it using the SSH or the other way?
So I'm guessing you're talking of the HTTPS, this,
Yes.
or the GitHub CLI.
Yes.
So, excuse me. So they are all good. They are all secure. They are all perfect. Everything just depends on your preference, your work requirements. For me, I prefer using SSH because I configure once and I just use it all the time. I've used HTTPS once, um, and I can't remember exactly why. I think what was the reason behind my HTTPS using? I can't even remember why. I think I was trying to pull a repo as another user or something, and I did not want to change my SSH configuration on my laptop. So I used HTTPS, pulled the repo, logged in through my browser, and pulled the repo using HTTPS. I think that was what I did. And that way, I was able to collaborate on one laptop using two GitHub accounts. So I can't remember exactly, but I think that was what I did. I have not used GitHub CLI yet, and it's one of the things I'll be trying soon. So it's kind of a new feature. I think GitHub CLI came out last year, 2 years ago, if I'm yeah. So I've not tried using GitHub CLI yet, and I'll probably use it and see what what it does. But SSH just handles everything for me because from my command line, I can do anything I want. Um, so does that answer your question?
Yes, it does. Thank you.
Right. Just 1 second. All right. So moving forward, going to the next part of what we are showing. We'll be talking about the git commands that we have. We'll be talking about the git commands that we have. We've already looked at git add. We've talked about git commit. We've talked about push. We haven't discussed fetch. We haven't discussed merge yet. We've discussed, oh, have we talked about pull? No, we've not talked about pull. And we'll talk about pull now. Git checkout and git branch. We've demoed git branch as well, which was when we moved from git branch master to git branch main. Git checkout, we'll see how it works. So you can create branches using two commands. Either git branch -m to create a new branch and check out to the new branch, or git checkout -b. So let's practice that. So let's say I want to, right now I'm in main and I want to create a new branch called dev, git checkout -b dev, and it takes us to dev branch automatically, and I can start working up dev branch. And I'll be explaining branching now. The same thing we did here, git branch -m main, and when we did it, it moved us to main branch. Now I can switch between dev and main. So now I'm back in main branch, and I'm back, and let's go to branch dev. But let me practicalize these two, so we'll be able to have good understanding of what these are. I am on dev branch. Let me make a change. I'll add my multiply function here. A times b. And this is const. I have this change on my dev branch. Let me commit it. Add multiply function. If I go to my main branch, I will not see this change. I will not see this multiply. So let's switch to main. That's git checkout main. It's not here. But when I go back to dev, I can see it here. Now, how does this happen? And that is what makes one of the things that makes Git powerful. Branching. Let's go straight to explaining how branching works. And we'll come back to explaining pull, merge, and fetch. How does branching work? Let's you just take your base branch as a straight line, which is this. This is our main branch. Let's switch to main. This is our main branch, this straight line. And you create a new branch. Let's call it new page, which is git. And to get this new page, you do git checkout dash b fit new page, or git branch dash capital M fit new page. This can also create a branch, but it doesn't take you to the branch immediately. It just creates the branch, and you still have to do git checkout. But with git branch dash M fit new page, it creates the branch and then it moves you to the new branch. When you finish working on this branch, you create a pull request. So let's bring it here. You git add files just like we did. You git commit, which is commit the new files, and then you merge. And it brings it back here, and your straight line continues. And that is how Git works. You have one base branch, and people can work on different branches and come back to merge the code back to the main branch. So that is how branching works. I'm going to pause here and ask, does anybody have a question here? All right, no questions. So we move forward. And I wanted to explain all of these things before coding, but I realized that it makes more sense to practicalize some of these things while we are going. So let's code. Let's branch. So we did our git checkout dev. I mean, we are now in main. So let's go back to dev. We added this in dev, but it's not in main. How do we get it to the dev branch? We do git push. Now, remember, we've not pushed anything to dev branch before. So if we do git push, it will not work and let's do it. We get an error. The current branch has no upstream branch. It does not exist on the remote branch. And we did not do the set upstream, which is dash u. This dash set upstream is the same thing as this dash u origin. So let's do this. We've already committed, we've added the file, we've added it to staging, that's git multiply, and we've committed. So now let's push it to the remote repo. So that's git push dash u origin dev. We come to GitHub. Dev had recent push 3 seconds ago. Compare and pull request. So I want to make a pull request from dev to main, which is merge fuse what I did in dev to main. And down here, I can see what I added, right? So let's create the pull request. Now, in a typical team, you call people that will come and review this. I can add a few people that will come and review it, and that's where the PR review process gets long and tedious and hard. But it's good. PR review is good, it's healthy, it helps the developer grow. It's one of the fastest ways to grow as a developer. Feedback is important as a software developer. You might think that what you did is perfect, but when other people look at it, they might find ways to poke holes into your code and then tell you, okay, this might be a better way to do it. And when you think about it, it makes sense. And you learn and you grow. So always ask for feedback, ask for reviews. When you create a PR, Don't be afraid. It might take a week to merge, but it's also an opportunity to grow, get feedback, and all that. Now, this branch has no conflicts, thank God. We merge pull requests, and that is where merge comes in. So we've merged the pull request. This change that we did in dev is now in our main, and I'll show you. So I'll go to, this is dev. I'll check out to my main branch. The change is not here yet, but I know that my main branch has the latest changes. If you come to your main branch here on the remote repository and you open your index.js, you can see multiply here. So to get the latest changes, I'll do git pull, and it will pull the latest changes from me, and I have everything here. And my history, my main is up to date. I can view commit history and also see other commits from every other person. So these are my commits. This is the first one, add some function. The next one, add readme, add multiply function. And this is the merge pull request commit here. And this is everything we've done this night. So we've covered git add, commit, push. We've not covered fetch yet, and we'll cover it now. Merge, which happened from here, from the pull request perspective. Git pull, git checkout, and git branch. Git fetch. Let's look at git fetch. Now, there are times when you're working with some people and they create a different branch. You don't have access to this branch. Let's say, for instance, I create a to be able to create a branch from the remote repository, new branch here. So let's call this branch demo, and we source is main. So it takes changes from main and updates the demo branch. So I'm creating a branch from main. Let's go back to this diagram. This is a straight line, and I do git checkout dash b. I'm creating a branch from this. If I create a branch from this, I'll copy this, I'll duplicate this and make a new branch. So basically, that is what I'm doing here. I'm creating a branch from this. So create new branch. So we have our demo branch. But this demo branch, I will not be able to see it locally. So let's clear this. Git branch. We have dev and main. These are the guys that I know. But we have a new branch on the remote repository. How do we see it now? So if you want to get it, what you want to do is git fetch. It brings down all the remote repos down. And the git branch should still not be able to show you that, right? But you want to see your remote repositories. So origin, and it's here. Now you can do git branch demo, and or usually I do it from here. I can switch to this branch, switch to new local branch, and it will take me to branch name demo already exists. Sorry, excuse. So switch to branch, check out the remote branch, and right now I'm on the remote branch called demo, and I can see all the changes there. So let's say, for example, I want to make a change here. Let's see if that's possible. Index.js. Let's edit you. Let's create a function that just returns what we add. returner. It returns, and the reason this is like this is implicit returns for arrow functions in JavaScript. So then we can commit the change, update index.js, beautiful commit message, commit changes. Now this is here. This change is in the demo branch, and I'm on the demo branch here, so I can pull this. So yeah, git pull remote demo. Sorry, oops. Git fetch, and then it was updated 17 seconds ago. Then switch to this branch. Check out the remote branch and open our index.js, and we can see the change we did on the remote repo. So that's basically it about Git. There is more, but for the scope of this lesson, because we're actually looking at the fundamentals and making sure that anybody that joins this class should be able to understand the problem Git solves, so the problem Git solves, and the anybody that joins this class should be able to learn how to move between branches, understand what branches means, and should be able to differentiate their local repository from their remote repository. I think what we've done now should be able to help you to understand that and explain to someone else in future. But that's after maybe I get a couple of questions and I answer a couple of questions from you guys. So, do we have any questions from what we've seen so far? If I don't get any questions, and I just ask questions as well. And yeah, no questions. Daniel, Olumide, Simeon, Joshua, any questions? Or I guess, was I able to explain everything very well that we understand Git very Git fully end to end? All right, Josh, your hand is raised.
Yeah, for me, I'm okay.
Sorry, I didn't get that.
Okay, I say for me, I'm okay. I'm good.
Okay, good. Daniel, seems you want to say something.
Okay, I can you hear me, please?
Yes, I can hear you.
Okay, I didn't get the gate. I know you tried to explain what it does, but I was trying to like get the whole picture of why do we need it? What do we do with it? I didn't really get that part. I think it seems you're a bit fast for us. I don't know if you can slow it a bit for us to pick up a few things. I know for you it's very normal, but for us we're trying to pick up on the things you're saying, and it's coming too fast.
Okay, okay, no
I
problem.
don't know.
Yeah, that's perfectly okay. Don't worry about it. It's yeah, yeah. Sometimes we can be a bit fast, and that's it's perfectly okay. So
I know that's what.
I'll go back to where we did something earlier. So I started by explaining what version control is. Git is a version control system, right? So I'm going to
Okay.
open this file one more time. Now, this is Google Docs, right?
Okay.
Um, I made these changes earlier. All right, you can see these changes. Now,
Okay.
you, on the other hand, you can come to this file. If I share this file with you, you can come to this file and make more changes. Let's say, for instance, someone comes here and says, everybody working on these documents does not have sense,
Okay.
right?
Okay.
What happens here is we can go to the version, to the history, and we'll be able to pinpoint the exact person that said that and when the person said that. 17th April, 8:21, Chilomokolo, right?
Okay. Okay.
That is one of the problems version control solves for us. We are able to go back in time. We can go back to the beginning of this document, to the very, very beginning, and see the first thing I wrote, which is this. We can, and we lost Daniel, but that's okay. And for some people that just joined, yeah, you can also follow up. You can also come back to where we are right now to see where we are at this point. Daniel, it seems we lost you, but I've not gone far. So you can go back in time and you can also come back to the present with version control. So this is for a document, bringing that back to code. Now you can have a code base that has a million lines of code. It is perfectly normal. How can you know who did what at what point? And if there is a bug at some point in this project, how can people easily go back, find where this bug is coming from, fix it, and move forward without doing a lot of Control Z, Control Z, Control Z, right? And that is the problem it solves. Now, Daniel, can you still hear me? Please
Yes,
confirm you
I'm
can
with
hear
you.
me.
I'm here. I'm here. I'm here.
Okay, great. Now, right now, the GitHub Masterclass repository, which is what we are working with, and is the perfect repository right now, the best repository on GitHub, has these changes. Let's say, for instance, Joshua wants to add a function to, um, let's say Joshua wants to add a function that gives you an exponent of exponentiation. Yeah, an exponent of the number that you pass into the function. Or, yeah, let's just use that. Joshua can write the code on his system, create a pull request, and I can merge it into this main. And everyone will still have access to it. So let's say, for instance, um, hmm, oh, no, don't worry. So let's use that example. Let's say, for instance, I am Joshua now. I'll come down to my system on my VS Code. I'll create a new branch and I'll have to go back to main pull, make sure I'm up to date. So let's say I'm Joshua and I check out, I create a new branch. I call it Joshua, Joshua branch. Sorry, git checkout dash B Joshua branch, right? So this is a new branch. This new branch is a duplicate of the main branch, but running on its own. It's a duplicate and it's independent of the main branch because you've already created the duplicate and it's on its own. Like we talked about in this diagram here. It duplicates and it stays on its own, right? Now Joshua will add an exponent function that takes a number and gives us the, let's say, raised to power 2 of the of the number that was passed in. So let's call it square, a square function. So this can be this or times 2, either of the two. That works for JavaScript. Now, if Joshua adds this to the code and Joshua pushes this, Joshua wants to add this to the main repo that everybody has access to. What Joshua needs to do is git add or git commit with a meaningful message that tells us what he did do. Add square function git push origin. This is to push it to the remote repo where everybody will have access to it. Right now, we don't have access to it. Git push -u origin -u Joshua, which is the name of the branch he's working on right now. Joshua branch. And this code is now in Joshua branch on the remote repository. So if I go to the list of my branches, and please, Daniel, confirm you're still following.
I'm here.
Okay, great. If I go to the list of my branches, I will see the demo branch from before. I will see my main. I will see dev branch. I will also see the Joshua branch. And Joshua, sorry I'm using your name. It's the first name that came to mind. Thank you for giving me the opportunity. So on the Joshua branch, you can see the changes that we just pushed, which is square, but it's not existent in the main branch. Now I want to get Joshua's changes into the main branch, this square. I want to get it into the main branch. What do? I create a pull request from Joshua's branch. GitHub makes it easy for you to compare and pull requests, but you can just do new pull request. Where is it going to? The base branch. Where is it coming from? Joshua branch. You can see the change you made. You create pull request, and you can see the file changed, which is this. This is the change that is being added. You can see plus plus here. We added an extra line to this multiply. That's why I have minus here. But this plus 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 are like the modifications we made. The reviewer comes and says, okay, this is good code. Joshua is a top-notch developer. Let's merge his pull requests, and Joshua will be happy with his life. So we merge pull requests into the main branch. Now, the main branch has the changes Joshua made. So let's open the index.js. This is the main branch. Let's refresh our page. This is the main branch. It has the changes Joshua just pushed, which is this square. Now, what does this mean for a big team? For a big team, oh yeah, so let me just pull this locally and then you can see it. So on my local hosts, I'll switch back to my main branch. It's not here yet. If I want to get that latest Joshua updates, I'll do git pull, which is give me what is in the remote repository that is in this main branch. Give it to me, put it in my local. I want it there. I want it in my local. I don't want it to be in that remote because I cannot use it there. When I do git pull, you see what Joshua pushed here, right? So that means right now, I can continue working on something else. I can continue working. And Joshua has given me what I need. Let's say I needed Joshua to finish a particular feature. Like I need this square function to calculate the square of any number, and I don't know how to write the square function. Or Joshua has the responsibility of writing the square function, and I need this square function to do something in my code. I can now pull this and keep writing my code. and everybody is happy. So does that make sense? Does that make more sense now, Daniel?
Yes, well, I think I'll just have to go through the recording after we're done and still pick up on some things you said.
Yeah, yeah. No, that's perfectly okay. So you can also reach out. That's okay. Then I
Okay, I'll do
want to
that.
show an example of, oh yeah, my GitHub. I usually have like some things going on. Your stars. So this is Grok. Nah, I think this system design is actually a good place to look. So you have like 26 commits. So this GitHub shows a list of system design questions, discussions, and how companies design their systems. And every time it's updated, how does it update it? You have commits, you have 26 commits. All you need to do is add these commits, and then you can visit, let's visit this. But I think this is a terrible example. Terrible example. Let's find a better example. I haven't looked at the Grok AI stuff yet. So let's see. React image magnify, React took from me. I think this should have a lot of collaborators. So you have lots of pull requests. All of these things, these are people collaborating and building a particular product. So this guy has a pull request that fixes scrolling to view, and this is the change. One change for that means. And this is it. Now, what this does is this change will now come into the master, and when you pull this package, you have the latest information from it without breaking anything, without having to. Oh, back in the days, what we used to do to review code was people would start sharing zip files, big code files. They will zip it and send to email. The other person will pick it up and start reviewing. Then they will start injecting their code one by one, looking for where it merges, where it fits. They'll start putting their code one by one, which was very, very frustrating. But Git automates all of those for us. So let's see, update watch observer. This is complex, but these are people that just they make modifications to something. After making the modification, they create a pull request and it's reviewed. If it's good to go, it's merged, and that is all. So this is what big companies, like big projects, use GitHub for, use Git for. So this is like this for React hook form. This is Grok AI, Elon Musk's AI. I wanted to look at their code base and see what they are doing different and what makes Grok special. So Elon Musk made it open source, and it's one of the things I'm actually interested in. So I haven't had an opportunity to look at it and see what they have, but big companies use Git to make collaboration and managing their projects easy. So that's it. Daniel, don't worry, feel free to reach out if you have any questions. Do we have any more questions? Additions, subtractions, exponentiations? All right. Thanks. All right. Thanks, Daniel. And I'm not Sal. Please, oh, please. I am not anybody, sir. All right. Thanks for joining our session. This is our first session, our very first session, and we're hoping to have more that will teach people how to join, how to break into tech, how to teach some skills, teach you some extra things, and some extra things that will help you in life and in your tech career, and also empower a lot of youth out there. I don't know, Maya, do you have anything to add?
I'm looking
Let's
up
see.
from the thank you to for this session. Thank you to everyone that's felt and to join. Um, if you join the page, the class was recorded, so just subscribe to our mail, you will get a recording of the class as well. So you can try to get some of the things that you need to you still need time to pick up the kind of only watch the contents.
All right. Thanks, Nawa. So, that's it, everyone. Thanks for your time. We appreciate your time. We'll be sending like Nawa said, we'll be sending the recordings to you all. So when the message comes in, don't send it to spam. Thank you very much. Thanks for your time. Enjoy the rest of your evening. Bye.
Bye everyone.
Bye.